So this is the fourth video in my video series for the fastbook-benchmark dataset. In the first three videos, I introduced the benchmark dataset, I went through document processing, and then I did a basic full-text search implementation. In this video, I'm going to score those retrieval results, and I'm going to implement the modified MRR at 10 and recall at 10 metrics. So much of the same installs as before, and make sure to download my utils.py script and save it locally and import everything from that because I'll be using that throughout this notebook. So the first thing I'm going to do is I'm going to download my data, and this will download and return a dictionary with chapter values as the keys and the notebook names as the values. In the next cell, I'm going to get the data, and I'm going to pass this notebook's dictionary to it, and this will get the stringified version of the notebooks in 2 or 3 chunks per notebook. I'm also going to load my benchmark because I'll need it to score the retrieval results. And I'm going to get my keywords data frame because I'll need that for full text search. Okay, and then I'm going to do some data processing. So I have my DB path is going to be fastbook.db. My chunk size is going to be 500. And I'm going to delete the database just to make sure we start from a fresh start. Then I'm going to iterate through my data items, and I'm going to process documents. This will give me my chunks. And then I'm going to load that data using my load data function. Oops. And I'm going to pass my documents, my DB path, and the chapter. And I'm actually going to move over this delete database here. And process documents was something that I built up in the document processing video, so check that out. It's also defined in my utils.py. So this will delete the database, and this should load up all my documents based on chapter and chunk size. And this should be documents. Great. So in each case, it loaded the documents, and then it did a test query and check the size of the results, and it matches the number of chunks in the documents. I'll now run full text search. So in the last video, I developed my full text search function, which takes the keywords, and it takes the top K, so the limit that I want to pass to the query. And I do have an assertion in that code, but just to show the output, I want to make sure that my results is the length of number of questions. So we run that and we get our results. Okay, so now we have our full text search results. We used Claude generated keywords, and we used SQLite's full text search functionality using those keywords, and we got the top 10, BM25 ranked results for each question. So now we're going to define what successful retrieval means. And to do that, I'm going to pick the first question from my benchmark, and we're going to take a look at the data structure. So this is one item in my benchmark data set. Here's the chapter and question number, the question text, which comes from the Chapter 1 questionnaire in Fastbook, the gold standard answer, which comes from the FastAI Forums wiki solutions, and the answer context is a list of answer components. So in this case, the single answer, there's a single component for the entire gold standard answer. So there's just one answer component. So there's just one dictionary in this answer context. So let's take a closer look at what that looks like. So this answer component is a dictionary. It has the component of the answer that we're addressing, which is the full gold standard answer text. In other examples, I split the gold standard answer into separate answer components. And here is the context. So this is the literal text from the fastbook which addresses this particular answer component. So I'm going to take a look at that next. And context is a list, and I only have one item in this list. But in general, I can have one or more contexts, and any of those will satisfy the answer component. Okay, so this is the text that I'm looking for. So my hope is that the full text search has retrieved this in the top 10 passages. So I'm going to define my passage as the one that I know that contains this. So here's the first question's results, and this is the second passage that's retrieved. And you'll see that here is the context that we're looking for. I use the ftfy library, and I use their fixed text function. And one thing I'm going to do is I'm going to save this as context. And then I'm going to say, check to see if my context is in my passage. And this is really boiling down to what the actual evaluation is for my retrieval results. Is my context in the passage? And in this case, it's true. To show another example, let's use the same context. That's for question 1. And let's see if it exists in the third retrieved passage. And we're going to see that it doesn't. So, okay, I know that it is in the top 10, it's in the second passage, but it's not in the third passage. So this is the core functionality that I started with, and now I'm going to incorporate this MRR metrics to it. So the first thing I'm going to do is I'm going to iterate through all of my answer contexts. And going back to the question data structure, answer context is a list of answer components. So I'm going to iterate through the answer components. I'm going to grab the list of contexts. And then I'm going to iterate through my results. So I'm going to get the rank and the passage in my results for the first question. And I'm going to start with 1 because my rank starts with 1. And if any, and I'm going to grab this right here. So if this check, fixed text of context is in fixed text of passage, if that's true for any of my contexts in my context list, then we have a match. So I'm going to run this, and this should print true, and it does. Cool. So now what I'm going to do is I'm going to add on to this something that captures the rank. So I'm going to have highest rank, and instead of printing true, I'm going to say the highest rank should be the maximum of my initial highest rank or previous highest rank, and whatever the rank is where I found a match. And if I print this out, this should be 2, and it is. Great. So I'm going to keep building on this. The way I've chosen to structure MRR, and this is a subjective choice, and this might change in the future, but I'm requiring all of the answer components to be found in the retrieved passages for the MRR to be a non-zero value. So this is how that implementation works. So I'm going to say my component answered is false. So this is a flag that I'm going to update if I get matches. If I do get a match, then the component has been answered. And if it's been answered, I don't need to keep iterating through my retrieved passages. I've captured the highest rank so far, and I'm going to break out of that loop. And so I'm going to run these lines of code and just take a look at what this outputs. So yes, we did find the component, and the highest rank was 2. And then the last thing is we need to handle our scenario where the component is not found. So if not component answered, then we're going to say print component not answered. And I'm going to run this, and it does not print it because we did find the component. So I think this is everything I need. The last thing I'll do is, instead of showing highest rank, I want to actually calculate the mean reciprocal rank. So for this one question, I'm going to do 1 over highest rank if highest rank is greater than 0. Otherwise, I want to output 0. And so our highest rank was 2. So the MRR for this question is 0.5. So I think I have everything here. So I can now wrap this into a function, and I'm going to call it Modified MRR. It's going to take a single question, and it's going to take the retrieved passages and a cutoff, which I'm going to default to 10 because I'm just doing top 10 for now. And my retrieved passages is going to be a subset of my results. And I'm going to set the highest rank to 0. And then I think everything else is the same, except now I'm not just looking at results for that one question. I'm looking at whatever the retrieved passages are for whatever the question I'm considering based on this one. So I've modified MRR. I take in question results and a cutoff. I cut off my results, and that's my retrieved passages. I have a highest rank that's set to 0. I iterate through each answer component. I get the context, set my flag, and then I iterate through each of the retrieved passages. And if there's a match, I capture the rank. And if it's the highest rank, then I capture that there. And I set my component answer flag to true. I break out of that loop. And then I return, so I'm going to make sure this is return 1 over highest rank if highest rank is 0, otherwise 0. And then if the component was not found, then I'm going to return 0. So if any component is not found, we don't bother for the rest of them, because if any component is not found, I have chosen to define my MRR to be a value of 0. So let's run this, and then I'm going to assert that my modified MRR for the question, given the results of the first question, is 0.5, and that's good. And then let me do another assertion where, let's go back up here. And instead of taking the first question and checking the first question's retrieved passages, I'm going to take the second question, and the components should not be found in this case, so it'll return a value of 0, which it does. Okay, so I have my modified MRR ready. The next thing I'm going to do is I'm going to define my modified recall, and I'm going to reuse much of this code. So I'm just going to copy this down here. Now, instead of, let's see, what I'm going to do here is I don't deal with rank anymore. And I'm not dealing with this component answered flag. So I'm going to get rid of that, and I'm going to get rid of rank. And then I'm going to get rid of this component answered situation. And we'll work on the highest rank return in a second. But what I'm going to do now is I'm going to see if I found how many of the answer components I found the retrieved correct passage for. So my modified recall is the percentage of answer components for a question for which there was a correct passage retrieved. So this is a more lenient one. It gives partial credit is one way to think about it. So if I did find that any of my contexts are in the passage, then I'm going to say, yes, I have found a passage. Otherwise, found will be false. And then before I go on to the next component, I'm going to say components found, append found. And up here, I'm going to say components found is an empty list. So what this does is that each length of components found by the end of this for loop is going to be the number of components I have. And then the value of found is going to be either true or false. So for the components I found, the value in this list will be true. For the components I didn't find, the value in this list will be false. So I'm going to return the percentage of components that I did find, which is just going to be the sum of components found divided by the length of components found. And let's run this again, except now the assertion is going to be for modified recall. And this should be 1 because the number of components found is 1 and the length of total components is 1. So this should be 1, which it is. And then I'm going to check it for my failing case, or I guess the components not found case. And this should be 0 because the sum of components is 0. Okay, so now I have both of my metrics defined. What I'm going to do is now I'm going to iterate through all of my questions and use my benchmark to get the results for the entire retrieval. So I'm going to have a bunch of MRRs and I'm going to have a bunch of recalls. And I'm going to iterate through the benchmark questions. The MRR is going to be the modified MRR of that question and the corresponding retrieved passages. And same thing for, I'm just going to copy this. Same thing for recall. And then I'm going to append that to the corresponding lists. And once that's done, I want to make sure that the length of MRRs is equal to the length of benchmark questions. And I'm going to do the same assertion for recalls. Okay, and then I'm going to convert that to a pandas series, so I can call sum and mean to check the values. And then I'm going to wrap this into a function. So this is called score retrieval. It takes the benchmark data set and it takes all of the results for the entire set of questions. And it does all of this. It runs these assertions, and then it returns the MRRs and the recalls. All right, so now I'm ready to get all of the values of my metrics for the entire full text search retrieval results. And benchmark results is not found. Oh, yes, because this is just benchmark. Benchmark, comma, results. All right, so the last thing I'm going to do is I'm going to check these values. And you can see this, I have some manual validation results. So this is an Excel file where you can see how I hand calculated the MRR at 10 and and recall at 10, the modified versions, for all 4 methods that I tried and for all 8 chapters. And the results were generated using this linked notebook. So hopefully if I run this, perfect. So all of my results are as expected. And this is the kind of full life cycle for search, retrieval, and scoring the results. So in the next video, I'm going to do this similar process, but now I'm going to do it for single vector search. And in the last video, I'll be running retrieval using Colbert models. So thanks for watching, and I'll see you in the next video.